This is Faculty of Engineering, and this is EAS3434 Aerospace Structure. So let's introduce the team. My name is Muhammad Amirul Fikri.
Hi, my name is Justin Raj Sopalan.
Hi, my name is Muhammad Al-Hikmah bin Muhammad Salihin.
Hi, my name is Vikneshwari.
And my name is Hasrina binti Amsali. Okay, for the past few weeks ago, we have assigned by Dr. Chia to find the structural components of the aircraft. So we came up with the different type of aspect ratio of different aircrafts, such as glider, civil and military aircraft, and acrobatic. So, want to know more details about it? Let's get started.
Hi there. So our topic is about different aspect ratio of wings for different aircraft. So what is wings? Well, if you are on an aircraft, you see at the windows, there's wings. So what is wing used for? Wing is used to generate lift. We can see this in birds. Birds will flap their wings to fly. But this is different with aircraft. Well, aircraft has complex structure to generate lift. So we will discuss more on different structure of wing to make different kind of mission. So there's military mission such as subsonic and supersonic aircraft. There are also civil aircraft which all of you might fly. There's a glider, and there's also aerobatic aircraft. We will also stress on different aspect ratio. So what is aspect ratio? Aspect ratio is actually the square of wingspan over area. So different aspect ratio of wing will produce different amount of lift. So there are several types of wing. For example, low aspect ratio wings. Low aspect ratio wings usually for military purposes. This is because it is high maneuver and high speed. Moving on, there's high aspect ratio wing. High aspect ratio wing is used for long range aircraft. This is because of its high lift produced by long wing. And last but not least is the moderate aspect ratio wing. This is usually used for general purpose aircraft. So without further ado, let's see the first type of aircraft wing.
Hi everyone, today I'm going to talk about the low aspect ratio of wing of a supersonic aircraft, but I'll be narrowing down to delta wing. Okay, let's start. Delta wing has a low chord, it's a large chord root, whereby the large chord root supports in high fuel volume, as well as it supports to minimize the speed of the aircraft because it has a large surface area. Next, when we're having a low relative wing, it helps in the weight drag of the aircraft. And moving on to the spar. The spar is very thick and adequate because it should be in a lightweight structure for its flying maneuvers in the sky, so that it has a high speed and maybe it can be controlled easily. Moving on to the leading edge structure of the wing. It has an adequate leading edge structure towards the wing where it produces a vortex lift for it to have an increased speed in lifting off. Well, however, delta wing also have its negative parts of the negative section, the cons part of the wing, whereby the delta wing has a large surface area which has a viscous drag for the same amount of lift. Viscous drag of lift, which is also same amount compared to the high aspect ratio wings. And delta wing also have a low lift drag ratio compared to a sweep wing.
Hi, Fikri is here. Thank you, Jaswin, for a good information there. So I'm going to talk about one of the greatest human invention in human history. Imagine this. You want a maneuver like a helicopter. You can lift off anywhere and you can land anywhere you want. But at the same time, you want a performance like an aircraft. It goes really fast. So the human actually engineered one of the greatest invention of all time, the teeth rotor aircraft. So one of the example of the teeth rotor aircraft is the V-22 Osprey made by Boeing. Of course, this aircraft is mainly used in. So the tilt-rotor aircraft is a complex aircraft, of course. This includes with the complex structure of the wing itself. The wing itself is quite unique. It is quite short. Well, if you can see here, the wing is long, but the end of the wing is the rotor. So I consider it as a short wings. So the aspect ratio of this wing is 5.1, and it is considered as a low wing aspect ratio. A low wing aspect ratio means that it generates less lift and can move much better than the high wing aspect ratio. Well, this is true because the Osprey has a rotor, so the rotor will do much of the lift work. Going into the interior of the Osprey wing, it is quite complex. As you can see here, the ribs is quite short. Well, this is due to the placement of the rotor. So the overall structure of the wing is compact to fit the rotor, the ribs, and the fuel tank inside. The ribs also must be lightweight, so it is made from the aluminium. The angle of attack of the wing itself is really low. This is because the wing doesn't need to generate much lift because it has a rotor. The rotor will make all the lift it needed. So the overall characteristic of a tilt-rotor aircraft wing is unique. Although it have a low wing aspect ratio, but it can generate lift much more than usual aircraft. So that is one of the unique characteristics of a tilt-rotor aircraft. That's all for me.
Hello guys, right now I want to share with you guys about the component construction of the glider. The glider that I have chosen is EAS3434. Basically, the glider is used for leisure activities, sports, and competitions. For this glider, it has a long and narrow shape of wing, thus it has a high aspect ratio which is 30.9 to enable it to generate more lift so that it can stay in the air for a long time. Next, I want to share with you guys a little bit information about the structure of the glider. The structure of the glider consists of complex composites such as carbon, aramid, and polyethylene fiber reinforced plastic. This permits a lightweight structure with the strength to carry up 170 liters of water ballast. Thus, it is permitting the widest possible range for wing loading in weak and strong weather. Next, I want to share with you guys about the design of the wing. The design that I want to focus on is spar and flaperon. First off, why do the spar at the root is thicker than the spar at the tip? This is because to give the greater forces to support the larger bending moments. For the flaperon is made up by the carbon fiber at the inner end and aramid fiber at the wingtip end. Thus, this is to give the maximum stiffness, low weight, and damage tolerance for the wing. That's all from me.
Hello guys, now I will talk about high aspect ratio for commercial aircraft. Why commercial aircraft need high aspect ratio compared with the fighter jet or military aircraft? It is because commercial aircraft, when you have a higher aspect ratio, the aircraft will be more stability. And also when it has more stability, it also has a more lift. And then the most important part is it can less induce drag. So the first enemy of the aircraft is drag. When you can reduce the drag of the aircraft, so basically logically the less fuel consumptions. Okay, now I will compare it with the glider. What the different glider and commercial aircraft? Both have higher aspect ratio, but the difference is wing area. You can see the commercial aircraft and the glider has a different wing aspect ratio. It is because commercial aircraft you must consider for the aerodynamic control, and also commercial aircraft need to transfer load to fuselage. Do you want to know what the load they need to transfer? First is the fuselage load. First is the fuel load. Most of the commercial aircraft has a fuel tank in the wing, and also they need to consider load of the turbine engine on the both side of the wing. Okay, next we will compare between old commercial aircraft and the new commercial aircraft. What the difference? And the old commercial aircraft, they use aluminum alloy on the skin of the aircraft, but in A350 it uses a composite material. when you use composite material, basically it will reduce a lot of weight when you use composite. When you can reduce a lot of weight, so more lesser fuel consumption, and it will increase in 25% for fuel consumption. And that's it from me. Okay.
Hi guys, now let's talk about aerobatic aircraft. Nowadays, it is common that there are some practices of flying maneuvers involving aircraft attitudes, and these aerobatic aircrafts are mostly used in training, recreation, and sports as well. So now let's move on to our topic about aspect ratio of wing structure. Compared to glider and long-range aircraft, these aerobatic aircraft have very low aspect ratio since it takes advantage of maneuvering. Let's talk about wing structure. Do you guys know that mostly the aerobatic aircrafts are made up of carbon fiber composite materials?
Yes, it is. For your information, carbon fiber composite materials can minimize the overall weight of an aircraft. So it is really good for an aerobatic aircraft to perform maneuvers easily and very well. What about the airframe of the wing structure? The airframe of the wing structure of an aerobatic aircraft should be stiff, and it should be very stiff in order to handle the stresses of aerobatic maneuvers.
One of the main goals of an aerobatic aircraft is to achieve neutral speed stability, which is eliminate the pitch responses related to airspeed.
Cambered airfoil does not fit for this purpose because it produces pitch down torque, which increasing with airspeed. So which one is more suitable? Of course, symmetrical airfoil. So most of the aerobatic aircraft are made up of symmetrical airfoil. Because of top and bottom surfaces of symmetrical airfoil are in same shape, the wing can generate equal upward lift, which regardless of whether it is the right way up or inverted. Therefore, in order to increase the speed of the aircraft and reduce drag force, the wing should have low aspect ratio.
So that's all from me.
Okay, to wrap up, each wing will have its own unique structural characteristics to fulfill the flight mission desired. Military aircraft prefer low aspect ratio wings. This is because it is much faster and high maneuver. The structure of military aircraft wings usually compact with components to fulfill multiple missions. Glider, in the other hand, of course, is a high aspect ratio wings as it is focused more on endurance. Aerobatic wings is designed in such a way that it can do critical maneuver. Civil aircraft also focus on high aspect ratio wings to reduce fuel consumption. There's also a future wing design such as the Boeing 777X with the variable aspect ratio wing where the wingtip has a hinge. Hopefully, there will be more innovation of structured wings in the future because the possibility is endless. That's all from us. Thank you.